All right, let's do it.
All right, let's do it. Um, Good. All right, and we are live for the second time in one day. I was just talking to Lars about how just going from one to the other is a little bit chaotic. We just literally went from meetup number 60 to meetup number 61. And here we are, joined by Lars. Good afternoon. I believe we are at the same time. How are you doing, Lars?
Yeah, great. Thanks for having me. It's really interesting to see the other talk as well. And yeah, glad to be here.
Good. Obviously we're changing gears a little bit. We just came out of an intro to Kubernetes session. If this is your first time, welcome to the Data on Kubernetes community. You've got all of our links in the YouTube description if you want to check us out on Slack, on Twitter, on LinkedIn. As you can tell, we're doing lots and lots of meetups about lots of different things. I have to say that machine learning is a hot topic. Lars, why is that? Why is it so cool?
Why is that? Good question. I feel like it has something magical about it, right? Like the first time you see like AI do something that you thought computers could never do, like I think that does something. So I think that's the main reason.
Okay. So, if, in your experience, what was the first time that you really encountered AI?
Oh, good question. That must have been like in university. So I actually had so my background is in computer science, and I remember having a course about AI, yeah, I mean that starts off with like like Deep Blue. I don't know if you're familiar with Deep Blue.
Yeah, Gary Kasparov. Yeah,
Gary Kasparov, exactly,
yeah,
right.
Yeah, that's super cool. That's cool.
Yeah. That's really cool. So that's actually what the course started with. And once you start digging into it and start finding out how these things actually work, that there's just something about that, and the end result of building a model or an algorithm and just seeing it live a life of its own and do its own thing. I think that's pretty cool.
It is pretty cool. So the thing is, Deep Blue, that was in the 90s. I mean, I'm old enough. I'm pretty sure I'm older than you, but I think that was in the 90s, right?
Yeah, I think so. And I wasn't even alive back then, but like just watching that match unfold, it's just really, really interesting. Yeah.
Cool. Talk about other things that you like, because we saw this in the description. You're also into Chinese culture and meditation. Tell us a little bit about that.
Oof. Okay. Yeah. So maybe meditation. So yeah, I got in contact with meditation in general. I think about 2 to 3 years ago. I didn't think much of it at the time when I encountered it, but later on, I think it was a couple of months, maybe a year after, I first talked to people that knew about this. I felt like I could really make use of some of the practices in there. And for the past 2 years, I have been making use of that. So I'm meditating daily and trying to apply meditation practice in my daily life. And I can always say it has really, been very beneficial so far. And I'm really enjoying doing this and getting the benefits from it. So
that's good. I mean, I think you picked an interesting time to start doing it, because with everything that we've been going through as a planet, I think it's probably a good time to get some balance in that. We can maybe take a look at that a little bit later. But that being said, if you want to go ahead and jump right into your presentation, as usual for folks that are in the audience, if you've got questions, put them in the chat. We'll get to them accordingly. But without further ado, Lars, if you want to go right ahead, I just have to ask, do you know Tim Vandekeer? Because he's asking already about your plants.
Already. Oh, that's quite quick. I don't happen to know him. I have seen him around.
You will very soon. He's an amazing community member of the DoK. So anyway, no, but he was very complimentary of your plants, and I do like your plants. Plants give oxygen, so that's good.
Thanks. Yeah, it's really nice. It's very nice to have these around me, and they bring some life to the environment.
Absolutely good. So
let's see.
If you want to share your screen, jump right in.
Yeah, let's see here. See if I can share it. I'm not using Zoom a lot. Can I share like an individuals tab here?
Don't worry. Yeah, we're all getting used to different tools.
Yeah, definitely. I think I'll use my entire screen here.
Okay. Yeah.
All right.
Like I said, I'll be monitoring the YouTube chat for questions. So if anything,
yeah, sure.
I'll just chime in.
All right. It looks like I'm gonna need to have to give Zoom some permissions to actually record my screen. So I'll be right back.
That's okay, no worries. In the meantime, we can think about different meditation strategies. Seriously, and the thing, because I'm a really impatient person, so like the idea of like, oh, I'm gonna sit still for 2 hours at a time and be quiet is something that in my mind is just like inconceivable.
Right.
But the good thing about meditation is that it doesn't have to be a religious thing. There are lots of different kinds of meditation, I think, as well. Is that for people, like I like running, and I think in some ways running can put you in a meditative state because you're concentrated, you're focused. But just getting 5 minutes to sit quietly, and also for people that aren't that into it, if you just go to YouTube and look for mindfulness meditations, there are tons. You can get 1 minute ones, 2 minutes, 5 minutes, however the amount of time that you want to dedicate. But yeah, oh good, we're already getting some lively stuff in the chat. This is good. This is the power of improvisation. Because you just never know what's going to happen. But looking at these different things and thinking about the future of what can machine learning bring to meditation, and what can meditation bring to machine learning, I think that's a question that we'll probably have to tease out a little bit more once we get Lars back with us. Oh, there you are. You're back. Good.
Here we go. Yeah, it took some time, but we're back.
It's all good. All right. That's part of the magic. This is part of the fun.
It is. So let's get the show on the road, shall we?
Let's do it.
All right. Let's do it. So, yeah, so I was watching the previous talk just now, found it very interesting, and I think like having the intro into Kubernetes is a very nice intro into what we're going to actually do now. Yeah, perfecting machine learning workloads on Kubernetes. I think it's good to start off by highlighting the need for this talk. And I think this tweet that I found describes it really well. It's by Gina. Gina is not relevant to the story, but she's actually quoting someone here. So I'm going to read it out. The story of enterprise machine learning. It took me 3 weeks to develop the model. It's been over 11 months and it's still not deployed. And this was actually a quote by a guy called Dinesh, who is an automation engineer at IBM. And if this is true, something's actually going wrong here. And I think there's a lot to that we can win here. So this was in the start of 2018. As you can see, the tweet was in 2018, but it's not much different, today. And we can back that up with some statistics. Which is that actually 87% of data science projects don't reach production. This was the result of a report that was done by Gartner, who's a big IT consultancy firm. And there's multiple other studies that actually come to the same conclusion. And what the Gartner study actually shows is that there's two main causes for the fact that they don't get into production. The first one is the data quality and data availability. So for most companies, either they don't collect enough data to do machine learning, or they do, but the data is very scattered inside the company, and therefore it's just not possible to build a machine learning use case. The second main cause, and that's the one I want to talk to you about today, is the lack of collaboration between data scientists, IT, and engineering. And I think this is one of the main problems, basically because all these people that we see here, data scientists, IT, engineering, they all speak different languages, and they all have to, all these stakeholders in these machine learning projects need to come together and understand ML, machine learning, understand the tools, understand the problems that they're trying to solve, and that's pretty tough. I think that's what makes machine learning a very tough problem. And that is a great.
I think you said the stakeholder. Oh yeah, you can algorithms. But this is such a common theme, and I think it's also great to start out with like these human sort of elements, whether it's interest in culture, meditation, things like that. Is because as much as we talk about technological problems, we're always talking about people problems. Like you said, people that don't speak the same language, or that there's tension or friction or silos or all these kind of things. I think the kind of question is, how can we all get more empathy into our organizations? Anyway, I'll let you handle that.
I really like that comment, Bart. I think that's really the case. And yeah, I think that's, if you can tackle that problem, the tech will follow. Even though we need skilled tech people, I think that definitely comes next. Yeah. So to conclude this slide, basically, as we can see, engineers are also part of the problem, right? And seeing as I have a background in computer science and I do some engineering, I feel it's also my responsibility to help solve that problem. Yeah, let's do that today. So I want to take you through 3 different sections of this presentation. And the overall goal of today will be to help you deploy machine learning workloads on Kubernetes. So I will start out by giving a brief introduction of what machine learning actually is, and I will gear it towards, the engineering mind, if you will, because we don't need to get into all the data science nitty-gritty to be able to deploy models. In the second section, we'll see how we can deploy some machine learning use cases and specifications that we get to actual Kubernetes deployments and some of the tools that we can use for that. And in the final section, we'll have a quick demo and show you how we can actually do that and implement a use case. So before we start, who is this guy and why should he be the one to tell you or to inform you on how to do this? So again, my name is Lars. I have a background in computer science. I hold a bachelor's from Leiden University here in the Netherlands. After my bachelor's, I started off as a machine learning engineer at a consultancy where I had the chance to help many different companies actually implement their machine learning use cases. After that, basically a spin-off of that consultancy, I started working as a software engineer at Deeploy, where we tried to take all the learnings from the machine learning implementations that we had, at those companies and merge them into a product that could help solve some of these problems. So that's what I still do today. Next to that, my main interests, professionally are AI, machine learning, and also distributed systems. So, that's where the Kubernetes part comes in, but also, distributed ledger technology. And yeah, Bart already briefly mentioned it, but yeah, I'm really in love with both meditation and plants, which is not relevant for this talk, but just some nice background.
It is relevant for this talk. It is relevant for this talk. And Tim actually even asked, what kind of meditation do you do? If you want to share that.
So I mainly practice 2 kinds of meditation, mindfulness meditation and open heart meditation, of which most of my time is spent on mindfulness meditation.
Can we get like a 20-second definition or like the difference between the 2?
Yeah, sure. So mindfulness meditation really tries to help you focus on the present, being mindful of the present. So one of the techniques that you often hear is focusing on your breath. And with open heart meditation, what you really do is you try to focus on emotions, how that makes you feel. You can meditate on certain connections that you have with other people and what you feel in them. And I know it sounds a bit fuzzy, but once you start digging into it, there's some hard science there. So
No. We talk about the data on Kubernetes community sounds plenty fuzzy. What you just described sounds amazing and very practical. Anyway, continue.
Nice. I like hearing that. All right. So let's get into the first part of this presentation, which will be the machine learning for engineers. And let's start with a machine learning 101. So basically, we have to start at like a problem, right? Because machine learning solves a problem. And that's some problems that are very hard to solve with regular software. And that's basically because some problems just have such a high number of parameters that are involved in those problems that it's near to impossible, if not impossible, to solve it with regular software. So an example would be, and this is a very common example in the machine learning space is the handwritten digits classification, or MNIST. And the goal of this classification is to take a handwritten digit, like one that you see in the corner, and classify it as being a digit. So let's say we take like one of the top images, we want to classify that as being a 0. Now, if you start looking at, how can I solve this with traditional software, or I wouldn't say traditional, but regular software? Well, this is pretty hard. So I think the image here is about 16 pixels by 16 pixels wide. 16 times 16, help me out here, is that 256? I don't know. It's like 2 to the 56, 2 to the power of 56 amount of possible states that this image can have. And if you have to program that with like if statements, and that's just not doable. So basically what machine learning tries to do is it tries to take an algorithm that is able to take in all of these parameters and try and train this algorithm to solve this classification problem, and train it with a lot of training data. So basically we get an algorithm, we train it, and we let that algorithm solve our problem. So the problem that we would try to solve here would be the MNIST classification. So if we put in a handwritten digit, the model would spew out number 4. And this is what data scientists mainly do. And there's a lot of frameworks for this. We're not going to dive into that today because we're diving into the Kubernetes part of this. But there's a lot of frameworks that data scientists use to implement these algorithms and to solve these problems. So a machine learning model like this, as we see it here, can be in the back end of any application. There's actually many use cases for recognizing handwritten stuff, digits, words. So it should be in the back end of any of applications, and it's a good thing they can be containerized. So that's what we'll do later up in the presentation. But that's something nice to keep in mind. Now, another aspect of machine learning that's relevant to understand when you try and deploy machine learning on Kubernetes is explainers and explainability within a machine learning space. So there's a lot of use cases that not just would be nice to have an explainer for, but sometimes it's actually required by law, by regulation, to have an explainer. So what an explainer basically is it's another algorithm that will help explain what the model does. So in the case of our handwritten digits example, it can be a model that tries to explain for a given output that the model has. So let's say it classifies a digit as the number 0. An explainer could try and show you which input values would be had been relevant for that prediction according to the model. And this is very relevant if you start to, if banks start to include machine learning into their operations, if they decide your credit score or whatever, it's very relevant to know why they give a certain credit score to a certain person. So it's good to know that sometimes data scientists create these explainers, and these also need to be deployed next to your machine learning model in order to give out, real-time explanations of output by a machine learning model. And then let's go into how machine learning is actually different from your average API that you deploy on Kubernetes. And I've broken them down into 5 different categories. So if we start with the compute intensity, the compute intensity of your average API is pretty low, right? Like the most intense thing it does is do a database lookup or some minor computation, but not a whole lot of number crunching usually. With machine learning models, that's very different. It really depends on the model. Simple models can be very similar to regular APIs in that they don't use a whole lot of resources. But when you look at more complicated models that try to, that need to do a whole lot of number crunching, these can require some more beefy hardware like GPUs. There's a specific piece of hardware called TPU, the Tensor Processing Unit, which is specifically made for machine learning applications. So this is already, here we can already see a difference between traditional regular software and machine learning models. Data intensity, they're usually very similar. So they, input can be images, text, whatever. It's the same for machine learning. So in that regard, they usually don't differ that much. However, when we get to monitoring, there's a big difference there. So with your average API, if you've listened to the previous talk, and I think it was also a talk by Alvarez, where you guys did some Prometheus stuff, you want to do some technical monitoring on regular APIs, like see how much CPU it consumes, how much RAM, network traffic, all that good stuff. When we go to machine learning, there's another type of monitoring that we need to do, which is statistical monitoring. Two main types of monitoring that you have there are outlier monitoring, monitoring for outliers, and monitoring for drift. These are machine learning specific problems that we try to solve, but I won't go too deep into them there. But remember that this is also something that data scientists sometimes want to deploy with their machine learning models. Now, if you look at when we actually want to update the software or the models with regular software, you want to update it when you find bugs or when you just want your API to do something different. With machine learning, there's a little bit more to it. So if the context of your model changes, so let's say that you switch from Roman or let's say our Western numbers to I don't know, so the Roman alphabet, and you're working with X's and stuff, that's not going to work. So that was what we call context change. But also when your data scientist has created a model that is more accurate than the previous model, that's moments that you actually want to update your model. And the final one is how to update them. So if you look at traditional APIs, usually there's a high degree of automation. So when software engineers write code and they push it to Git, for example, there's a CI/CD pipeline commit that starts to run, and the code will get automatically deployed into hopefully a Kubernetes environment. When we look at machine learning models, there isn't really yet a very standardized way to go about this. So the data scientist would train a new model, but how to actually deploy this, that's it's not an open question. There's standards that are starting to form, and we will talk about that today. But there's no winner yet, as in as you have with Kubernetes. And then finally, if we try to put this all together, so the knowledge that we've had so far of machine learning is, this could be a very simple form of how you would implement this. It might already be helpful to start thinking about containerization and like how these different components would fit into a different container, which is kind of a spoiler, but let's give out the information. So what we see here is a machine learning model deployment that would just function as any other API. So there's, I don't know if you can see my mouse, I think you can. A request comes in, there's a pre-processing step usually. So that tries to, if you send in an image to a model, it can resize the image or, do some other fancy stuff with it. Then it goes into the model. The model actually tries to come up with a prediction or an output, and it goes into post-processing where it tries to synthesize that output into something that is useful to, maybe other applications. And then also we talked about explainers. An explainer is usually deployed next to it to fetch a live prediction. Now, if we go into a little bit more advanced, so we also talked about monitoring. This is what a deployment would look like if we included the machine learning monitoring, right? So we would have a logger, which basically sends all the incoming requests that come to the model to a different subsystem, which is the alerting system. And then, you can have any number of detection model systems here that are provided by the data scientist, and they could generate alerts like, oh no, like the model starts, predicting very weird things. You should take a look at it. Like that can be a simple way of saying we need to update the model. Okay, so yeah, this is the machine learning 101 for engineers, and I hope you have an idea of not like a little bit of what machine learning is, and also how how as a system machine learning would look like in a deployment in an infrastructure environment.
Okay, we got a couple of questions.
Okay.
Is the explainer a form of metadata then?
It's not a form of metadata. So what an explainer is usually an algorithm, and because your input space for the model is usually infinite, it's not metadata because we don't know yet upfront what kind of predictions will come in. So we have to on the spot try and explain a specific prediction. So, but if you look at, I mean, we can go back to the example here. If we look at this example, if we, anyone can write a new number that in that form has never been written before, and then, your model needs to, for that specific number that you wrote, come up with why it thinks that is a number 4 or a number 2. So, but it is, you could consider it metadata to your explanation if that's how you put it, but it's not metadata as in it's data that's pre-stored and you can just put out whenever you want.
Okay, good.
I hope that answers the question.
No, we got a couple other questions though too. This
Cool.
one, do you also want A/B testing with ML models?
Yeah, very good question. Yeah, definitely. You usually the data scientist can already try and do some testing himself and see how the models compare. With when you look at traditional software, sometimes behavior, you need to have two different versions of your software next to each other. If you're looking more at like machine learning models that try to increase engagement, and you don't know yet, what increase in engagement a certain machine learning model can generate, then definitely you want to A/B test that and see which model performs better. But sometimes your data scientist can already give you a sneak peek and tell you which one will do better.
Good. And one last question. Is input data quality and validation also part of pre-processing?
Yeah, so usually you would have some kind of input validation in place. Preferably, it would not reach the model if the input is not correct. So your pre-processing step could definitely be some kind of validation, or it could convert some data types into data types that your model understands. So in that sense, definitely your pre-processing step can be both validation and some arithmetic to get your input into the right shape. Yeah.
All righty, keep going.
Cool. All right. So let's look at how we can take what we just saw, the schematic, and how can we translate this into something that we can deploy onto Kubernetes. And the good news is you don't have to start from scratch. There's a lot of great tooling out there that takes a lot of the work out of your hands. There's I'm just mentioning 3 open source frameworks here. I bet you there's more, but these are the ones that I'm familiar with: BentoML, Seldon Core, and Kubeflow Serving. And they all provide tooling for basically 3 different things, sometimes more, but that's more fancy. The first one is the deployment of machine learning files. So when we think of machine learning files, it's basically the artifact that data scientists create. So it's the output, basically the model in file form. And that's what you want to deploy into Kubernetes. And then these frameworks can do that for you. So as an engineer, as a cloud infrastructure engineer, you don't have to start writing Python and build it into an API. All these tools do that for you. So that's very nice. They also provide networking tools. So we'll get into specific networking tools later, but they do networking for, when you deploy a model. Sometimes they also implement A/B testing capabilities and the routing for that. So that's really cool. And also, finally, not unimportant, scaling. So they provide you with ways to automatically have your models scale once more traffic comes in, or that kind of stuff. And this is all available natively on Kubernetes, of course. But if you had to do this by hand, it would just be a lot more work. And what these all have in common is that usually they implement a custom resource definition. I think if you've watched some data on Kubernetes talks before, you will know that what it is, but I'll give a brief summary. So a custom resource is basically an entity that extends the Kubernetes API, right? So within Kubernetes, we have pods, we have deployments, we have services. But if you want to create your own entity that contains its own data, we use custom resource definitions. And all of these frameworks implement some form of a custom resource definition. Yeah, I think we should go and look at that later. And today I want to dive into one of these frameworks, the one that I work with almost on a daily basis, which is Kubeflow Serving. So it's an open source project that was initiated by Google. Actually, Kubeflow, which is the parent project, and then Serving is like a child project, was all initiated by Google, but it's been picked up by a lot of open source contributors that are not necessarily linked to Google. Yeah, so I was talking about Kubeflow Serving, which is a child of Kubeflow. And basically what Kubeflow intends to do is it tends to simplify deployment of machine learning models onto Kubernetes. So that's the main premise. And then Kubeflow Serving is the actual one of the actual components that does that for you. If we look at the dependencies that Kubeflow Serving uses, I told you we'd be coming back to this. So for networking, it uses Istio. If you haven't heard of Istio before, it is a pretty big open source project building on top of Kubernetes, and it basically provides a lot of networking components. So it creates a service mesh. It has some form of an ingress, and that's what Kubeflow Serving builds on top of. Then for deployment and scaling, it uses Knative Serving. So this was also mentioned in the previous talk. But if you haven't attended that one, the Knative is basically a serverless framework on top of Kubernetes. So it allows you to deploy applications that are serverless. So they can scale down all the way to 0. And once traffic comes in, they can scale up. So that's also what Kubeflow Serving uses. And finally, it uses a cert manager to provision TLS certificates to applications that you deploy. Okay, so yeah, let's move on to the custom resource definition that Kubeflow implements, and that helps you deploy machine learning on Kubernetes. And the CRD in question is called the Inference Service. And I've given an example of what that looks like here. So this is, I think, the simplest machine learning deployment that you can make using Kubeflow Serving. And we'll go through what each component in this inference service means. So we start off with a predictor, which is basically the class that specifies your machine learning model. So this is where you would start describing what your model looks like. Now, if we continue, we specify a machine learning framework. So if you remember before, in a couple slides back, data scientists use a lot of different frameworks to build their machine learning models. Now, we as cloud infrastructure engineers, are not necessarily familiar with these frameworks. But what Kubeflow Serving does is it provides an API for you to select which framework your data scientist used, and then you can select that framework and go from there. So that's really cool. So we see here scikit-learn, which is a model framework for machine learning. We see a protocol version, which is not very relevant. It just specifies how to interact with the API. And a storage URI. So this is where, this is a very important part. So we specify here reference to blob storage. Inside of that blob storage, that's where actually the models are saved. So the machine learning models are stored into blob storage. And when we deploy it onto Kubernetes, the services pull the model files from blob storage, and they initialize and serve them. So here you can see we reference to a Google Cloud Storage link, basically where the model is saved. All right, so we can make things a little bit more complicated. So we can go to a little bit of a bigger inference service, but don't be afraid. We'll pick it apart one by one. So we start with a transformer. This would be your pre-processor or your post-processor. So we can implement pre and post processors as transformers, and we can implement those as custom containers, which is really nice. So we can specify, like I can see here, a specific image that we can pull from Docker Hub or wherever your Docker image is stored, a name, and some other environment variables that you might want to use. Min replicas. So as I mentioned before, Kubeflow Serving makes use of Knative Serving, which allows us to scale all the way down to 0, which is very nice. And that's actually what we do here. So by setting the minimum amount of replicas to 0, we allow ourselves to scale down to 0 if there's no traffic. So the machine learning model will be undeployed, and once traffic comes in, we'll quickly deploy it again to serve those requests coming in. And then finally, we specify resources. And this is also very important. What we do here is we basically tell Kubernetes how many resources your machine learning model will need. So CPU, memory. So that's very important, because some models require a lot of resources, but also you don't want to over provide. So you don't want to give machine learning models, 10 times the amount of resources that they need, because resources cost money. So you want to prevent that. All right, let's go to the last spec that we're going to look at. Another thing that we can do is we can have node selectors. So if you're familiar with Kubernetes, what node selectors allow us to do is it allows us to specify a specific node pool within Kubernetes that we want to deploy this model on. So let's say you have a machine learning model that requires a GPU. We can actually select here a node type that has a GPU. Logging, so this would be important for the alerting system that we discussed earlier. I'm not going to dive into this too much, but just know that it's there.
We do have a question from a previous point. Do you also scale down the transformer?
Yeah, so actually, that's a very good point. So it's specified here for the predictor, but we can specify this also on a transformer and the explainer and every other component that you would have. So it's very nice, because for every component is different in resources, in how we want to deal with it. So it's very nice that per component we can select how our deployment strategy, basically. So yeah, that's pretty cool. So yes, you can also do that for a transformer. And we discussed the logger, and then finally the explainer. So the explainer that we talked about, sometimes you need to be able to explain in real time why a certain prediction was made according to the model. And we also have an implementation for that. And here we can see explainer alibi, which is again, it's a machine learning framework for explainability. So we don't need to know a whole lot about alibi. We just need the data scientist to tell us, oh, I used alibi, and then we know, okay, let's implement it like that. Cool. So let's end with this cheat sheet I made for you guys. So if we combine everything, if you want to deploy machine learning on Kubernetes, there's a couple of things that you need to ask your data scientist, and then you will know, because of what we just discussed, how to deploy it. So the first question would be online or batch. Will we need to serve predictions live? You know, is there some client, someone on a computer that needs a prediction straight away when he inputs something? Or do we need to, do we run something nightly, and do we do it in like thousands of predictions at a time? And do we store it somewhere for later use? That's something to keep in mind. That translates to the min replicas that we saw. Do we want to scale down when we have an online setting? Probably not, because if we have an online setting and at any point a prediction can come in and we want to serve that straight away, we don't want to scale down to 0. Pipeline format. So ask your data scientist, do you want an explainer? Do you have pre-processing steps? We can implement those using the transformer, predictor, and explainer tags in the Inference Service. Another important thing to ask your data scientist is, are you familiar with Docker, or do you want me to straight away deploy your machine learning model as a framework file? So if he knows Docker, great, have him wrap it in a Docker image, and then using the custom Docker image that we saw earlier, you can use that. If he doesn't, also fine, because Kubeflow Serving provides us with those tools.
Another question, so you can use different explainers in this configuration. It's not necessarily bound to alibi?
Yeah, correct. Yeah, so very good question. So there's a couple that are supported out of the box, but if you have, like a very exotic framework that you use, or you build something custom, you can just wrap that into a custom Docker image and use that instead. So you're not bound to what they provide out of the box. Yeah. Okay. Hardware requirements. So, what does your model need? Ask your data scientist. Is it heavy? Does it need a GPU, or will it be fine with a CPU and RAM? We can specify those using the node selector and resources that we can specify. And finally, the monitoring. Do you need some kind of outlier detection or drift detection? If yes, implement it using the logger. And if you're interested in the specifics of some of these tags, definitely go to the Kubeflow Serving repo. I'll link to it in the Slack channel later on, so you can take a look at it yourself. But these are the main points that you need to know in order to actually deploy it.
Okay.
So now that we know how to make this translation, let's actually do it. So I'm gonna change my, oh no, not yet. Let's look at an example machine learning use case, and let's actually implement that. So let's imagine that we work at a bank, and the bank wants us to deploy a credit scoring model, and the data scientist tells us it is a scikit-learn model. Okay, that's good to know. The credit score needs to be assigned once the request comes in. Okay. We need to be able to explain the outcome to customers. So if the customer wants to know why to get a certain credit score, we need to be able to provide it to them. The data scientist that built this model has no Docker experience. Unfortunate, but also fine. The model and explainer requirements are shown here. And then we don't need extra monitoring. So there won't be any outlier or drift detection so far. Just a simple plain machine learning deployment. Okay, well, we can fill in the cheat sheet, right, with all these facts. So let's do that. So online or batch, well, it says here that the credit score is assigned when the request comes in. So that has to be online. Pipeline format. Well, there's no monitoring, we just heard, but there is an explainer. So we have a model explainer. No pre or post processing was also mentioned, so no transformers. Our data scientist has no Docker experience, so we'll need to use the model framework. It was specified here, scikit-learn. So we can just use the Kubeflow Serving tags in order to deploy that. We got hardware requirements from the data scientist. So this is very nice. You won't always get this. So sometimes they train them on their computer and they have no idea of how heavy it would be. So you might have to experiment, but in this case, we just get them. So we can just copy those. And finally, no extra monitoring. So yeah, let's actually do that. So I'm going to stop or switch my screen sharing here. And switch over to a different screen.
We got one other question. What is your opinion or experience on using open source tools in Kubernetes for machine learning versus something like cloud platform provided like Azure machine learning?
Sorry, come again.
What is your opinion or experience on using open source tools in Kubernetes for machine learning as opposed to something more cloud platform provided like Azure machine learning?
Very good question. So for me specifically, I try to stay away from the cloud solutions because they're not compatible with each other. But if you have a company that's that only works on Azure or only works on some other cloud environment, then definitely use it. The open source versions, because they run on top of Kubernetes, they work with every cluster in every kind of cloud. Yeah. Okay. So I'm going to share my screen here, and let's actually deploy this. So on the right side, what I did is I have here an Amazon S3 bucket. So remember how these models are stored on S3 or on any kind of blob storage. So I did that. So the data scientist that provided me with their model file and their explainer file, I've uploaded them to a bucket called Deeploy DoK. So I have here the income folder. I have a model folder with the model file, the sklearn file, and an explainer folder, which is a SHAP explainer. We did not see that in the case, but I happen to know that. Okay, so let's grab our the requirements that we had and the cheat sheet that we fill out. So I'm gonna show those here. Is this legible? I think so, right? Okay. Yeah. So
looks good to me. If we get any comments, I'll let you know.
Okay, cool. So yeah, on the left side here, what I did was I actually implemented the requirements that we got here. So let's walk through them. So we have an Inference Service. It has a name, DoK income. I'm going to deploy it in the default Kubernetes namespace. We have a predictor, which has min replicas 1 because it needs to be an online model. So we don't want it to scale down to 0. So we always need to have at least one instance of our model available. We use the scikit-learn model framework. We specify the resources. So these were the resources that were provided to us by the data scientist. We specify a runtime version, which is not very relevant, but just tells us the version of Kubeflow Serving that we want to use. And here we reference to basically the location in the blob storage where our model is located. So you can see I specified the model folder specifically. So that's where all the files are. We don't specify a specific file because some machine learning formats have multiple files. So we select a folder for that. For explainer, we have an alibi explainer. Same thing with the resources. So we specify resources here. We have our runtime version again. We link to the blob storage, but this time the explainer location in the blob storage, and we select a explainer type. Now, I did not include that here, but definitely ask your data scientist what kind of machine learning model they want to deploy, if they want to deploy an alibi explainer. Finally, min replicas 1, because like we also need to serve explanations to customers live, so we won't set that to 0 either. Okay, yeah, let's deploy this. So for those of you who are not familiar with the screen on the right here, this is a tool that I use. It's called Lens. It's basically an IDE, integrated development environment for Kubernetes. So if you're familiar with Kubernetes, it will give me a very quick overview of all the different entities within Kubernetes, and it's free. So if you haven't tried this yet and you're diving into Kubernetes, definitely give this a go. So what we're looking at here is a Kubernetes cluster that I deployed using Amazon EKS. It's version 1.18, I believe. And I installed Kubeflow Serving here. So to show you, remember, Kubeflow Serving has a few dependencies. One of them is Istio, so I deployed Istio here, as you can see in the Istio system namespace. If we go to the Knative Serving namespace, we'll see that we also deployed Knative Serving because this was our dependency for scaling and serverless capabilities. And then if we go to the Cert Manager namespace, we'll see that I've also deployed a few Cert Manager pods that will allow us to generate TLS certificates on the fly. Finally, there's only one pod for Knative Serving, which is the controller manager, and this is the pod that will basically do all the magic and deploy our model once we put it onto the cluster. So let's put it onto the cluster. So I'll just go into my terminal here. I'll see if I can do the most simple command, kubectl get nodes. It will show me that I have one node. It is version 1.18.9. And yeah, we can get started here. So it's as simple as just applying this file to Kubernetes. So we'll do that now. So kubectl apply file, and I did call it inference.yaml. So we'll run this. And it tells us the inference service has been created. So if we look to our right, already we can see some things happening. I don't want to look at that yet. What I do want to look at is the inference service custom resource definition that I talked about earlier. We can now see that our DoK income model that we specified here has been deployed in the default namespace. It will also tell us whether it's ready or not. And it just went to true. So actually the model is ready to receive requests, and it also gives us a URL. And if we go back to the default namespace and look at the pods that are in them, we can see that Kubeflow Serving deployed two pods. The first one is a predictor. As we specified here, we have the predictor spec, and it has all the resources that we specified. And we have the explainer pod. Exact same story, also has the resources that we specified on the left side. Yeah, so now comes the most interesting part, which is actually making a request and getting that prediction from the model. So how we can do that is we can go to the URL that it provides us with. So because I set up Istio and a domain, I have here a doc.deploy.ml domain. So I can copy that. And then if I go to, I create a shell script. And actually I already secretly have the the URL in here. So we're going to use a curl command, which is just a tool that makes HTTP requests for you. And we're going to make a request to the URL that was just provided to us by the interface. And if you look into the Kubeflow Serving documentation, it will tell you exactly how to form the URI that you see here. For now, we can just assume that it's v1 models and then the name of your model and then predict. And we're also going to give it some input. So we're not just going to call the model, but we'll also provide it with input, which is very important. Otherwise, it won't know what to create a prediction on. And I put the input into a JSON file here. So we can see that on the left side. So a very simple JSON file. It defines the instances, which is the amount of cases that we want to fetch a prediction for, which is basically just an array. And then this is the input that we want to fetch a prediction for. So it's an array of numbers. Remember, we were deploying a credit score model. So all these numbers refer to a person and a specific character trait of that person to decide how credit worthy this person is. I'm not going to go into the details of the input, but let's just take it as is. And then what I can do now is I can run this shell script, which will then make the request. So I use the Z shell. So I Z shell infer.sh, and we get a prediction back instantly. So this was very fast. So so remember, we sent this input to the model, and it gives us back a JSON with the predictions and 0. So, you know, as a cloud infrastructure engineer, we don't necessarily know what this means. You know, usually the data scientist knows exactly what this output would mean. The most important thing is that we just deployed a machine learning model onto the cluster, and we were able to fetch a prediction from it, which means that we can now start integrating it into the rest of the application. Remember, we also deployed an explainer. So if I just replace the word predict by explain, we can make the same. Oh, I think we're getting an error from the explainer. I don't think it currently likes the input that we send it. But if you deploy an explainer next to your machine learning model, accessing explanations from the explainer is as simple as just changing the URL very slightly. So yeah, we have a machine learning model live, and this is what we were hoping for, right? This is the stuff that we were trying to do during this talk. So I'm going to switch my screen again to the presentation. Let's get this up here. Let's remove me from this screen. Cool. All right. So some closing thoughts on what we did today. Deployment of machine learning does not have to be hard. As we just saw, like, I know we implemented a very simple use case, but you know, like, if you have these tools and you know how to work with them, they can be infinitely complex, and you know how to boil it down into a very simple single custom resource definition. It doesn't have to be hard if you know your tooling. So that's what we just did today. Also, very important, know your machine learning basics. So the stuff that we discussed earlier, know a little bit about some of the frameworks and some of the setups, the model setups that we have.
Oh, we got another question.
All right.
From Nelly. What's up, Nelly? Was the model predictor already trained, or is it training on the JSON input?
Very good question. So data scientists, their job is to actually create the model. And what training means is they train an algorithm on the data. So what we just did was we deployed a trained model, and we fetched a prediction from it. So there's no training in what we did so far. The training usually lies with what the data scientist does. Yeah.
All righty. Good.
Okay, it also doesn't have to be hard if you talk to your data scientist colleagues. So don't live in silos. It's going to be very hard. Actually approach these people, ask, what are you working on and what can I do to help you get your model into production. Establish your workflow with your data scientists. So we in our space we call this machine learning operations, MLOps. Find a way of working that's nice. These models are going to need to be updated frequently, and if you don't have a workflow with your data scientists, that is going to be a pain. So definitely establish that. Start simple. Don't try implementing this crazy AI case that is going to be very painful for you to implement. Start simple. Like have a simple model, have a simple setup. If you're just getting started with this, try to deploy some of the sample models that are provided. And get your machine learning use cases to production. So very brief, Bart. If you have deployed, models a few times with Kubeflow Serving, you'll see that there's a lot more actually to getting a production-worthy machine learning use case live. So we're talking authentication, monitoring, explainers, all that stuff. So that's the company that I work for now, Deeploy, and we try to, we actually built a tool that helps data scientists manage their own machine learning deployments on Kubernetes using Kubeflow Serving. So if you're looking to level up your machine learning deployment game, feel free to give us a call. And with that, I would like to close off. So if you have any questions, feel free to ask them now or reach out to me. I will be in the Data on Kubernetes Slack channel as well, a little bit after the talk to answer any questions that you might have. You can follow me on LinkedIn, Twitter, and make sure to also check out the Deeploy website to see if it's interesting to you. And with that, Bart, thanks for having me.
Absolute pleasure. I think we can all agree that Deeploy must be a good place because you're working there, and they're very lucky to have you. So but seriously, that was a fantastic presentation. Very, very nice, very technically focused, very easy to follow. The comments were evidence of that. We will have a couple of other questions for myself as well as from other attendees that would like to continue the conversation. But seriously, very, very good. This was meetup number 61 and is definitely one of the more solid ones that we've seen. So Lars, we will probably have to have you back. That being said, can I get you to stop sharing your screen really quickly, or maybe you already did?
Yeah, I already did. Yeah.
Cool. You may have missed the previous meetup, but we have a tradition in the Data on Kubernetes community. While you were giving your brilliant explanation, our good friend Angel is in the background drawing. So let me know when you can see my screen. So here we have a very interesting depiction of a lot of different things, kind of showing you as a very fair and balanced figure between these different sort of areas that can be conflictive, as you mentioned in the beginning. And it also kind of came full circle with the cheat sheet of the different things to keep in mind there about how to interact with the, the data scientists, engineers. We have IT, we have DevOps people, we have all these different mindsets that can very often be conflicting. But I think that's a nice depiction. And a little bit of retro stuff. Apart from Deep Blue, Anka wasn't sure based on your age if you would get the HAL 9000 reference. I think you probably do.
I know the reference, but I'm quite ashamed to say I haven't seen it yet.
The Data on Kubernetes community is a space that is dedicated to learning. So don't worry, Lars. That is a reference to 2001 Space Odyssey, which is just a way of saying that I'm old and Angel is even older, not by much. He's gonna hate me for saying that. But anyway, a very, very wonderful presentation, very well-rounded, technical, wasn't a vendor pitch. If for folks that were in the audience, if you have a community and you want someone to give a great talk, you look no further. Lars, that was really, really good. So yeah, I think now the next step is to put these practical tips into practice, as you clearly indicated how that can all be done. And like I said, we still have some questions we didn't get to. so we can continue the conversation in Slack. But anyway, thank you very, very much.
Yeah, let's do that.
Sorry for having to get started with a little bit of speed bumps because literally running from one meetup to another, but that's just how these things go sometimes. So anyway, thank you very much, Lars, and have a wonderful day.
Thanks for having me, Bart, and yeah, talk to you later.